All right, so we're going to continue on with section 3 of unit 5, and we're going to start talking about properties of metals, nonmetals, metalloids, and how the kind of periodic table is all put together. Okay, so the elements of the periodic table can be divided into 3 main categories. You have your metals, your nonmetals, and your metalloids. Your metalloids kind of show characteristics of both metals and nonmetals, and so we're going to talk about what those characteristics are. All right, so properties of metals. Big thing about metals is that they are very good conductors of electricity, which means that electricity will flow through them. Think about wire. Metals are also shiny. Metals are ductile, which means that they can be stretched into thin wires. We can flatten them. We can make them into sheets. That's what ductile means. Metals are malleable. Sorry, with sheets. Metals are malleable, which means they can be flattened into sheets. Ductile means they can be stretched into wires. Chemical property of metals is its reaction with water, which will result in corrosion, also known as rust. A lot of you know it as rust. That is a chemical reaction. It happens with water, sometimes air, sometimes both play into that buildup of corrosion. All right, so properties of nonmetals. Nonmetals are poor conductors of heat and electricity. Nonmetals are not ductile or malleable. Our solid nonmetals are brittle and easy to break. They are typically dull, and many nonmetals are gases. All right, so metalloids are metal-like substances, and they have properties of both metals and nonmetals. They are solids that can be shiny or dull. They conduct heat and electricity better than nonmetals, but not as well as metals. And they are ductile and they are malleable. All right, so elements in the periodic table are also grouped into families, which are the columns. Columns go from top to bottom. Elements in the families have similar properties. Elements are also categorized into periods or horizontal rows. Periods go left to right or right to left, however you want to look at it, side to side. Elements in periods do not have similar properties. All right, so kind of compare and contrast between families and periods. All right, families, they have similar properties. Okay, elements in each family have similar but not identical properties. For example, lithium, sodium, potassium, and other members of that family are all soft, white, shiny metals. All elements in a family have the same number of valence electrons. That's important. Okay, all elements in a family, in the same family, have the same number of valence electrons. They will not have the same number of neutrons. They will not have the same number of protons, but they will have the same number of valence electrons. Periods. Each horizontal row of an element of the periodic table is called a period. The elements in a period are not alike in properties. In fact, the properties change greatly going across the periods. The first element in the period is always an extremely active solid or extremely reactive solid. The last element in the period is always an inactive or an extremely unreactive gas. All right, so families, and I'm going to kind of fly through these. You can follow the colors. This is going to be the families that we talk about and we focus on. Excuse me. Yeah, not a lot of talking. We'll talk about each of these families as we get going. All right, so hydrogen, the hydrogen square sits atop family, but it is not a member of that family of the alkali metals. The hydrogen is not a metal. It's not going to be a member of that alkali metal family. So hydrogen is typically in a class of its own. It's a gas at room temperature, and it has one proton and one electron in its one and only energy level. Hydrogen only needs 2 electrons to fill up its valence shell. Okay, so it only needs one more electron. It either needs to gain an electron or give up an electron to be full in its outer shell. Alkali metals, where we go first. So the alkali metal family is found in the first column of the periodic table. Atoms of alkali metals have a single electron in their outermost level. In other words, they have one valence electron. They are shiny and they have a consistency of clay and are easily cut with a knife. This family is really reactive. Okay, They want to give up that one electron really bad to be full. Okay. So even lithium has 3 electrons, 2 on the inside, 1 valence electron. It wants to give it up. It wants to give up that electron, be stable. Okay. Last slide of today with alkali metals. They are the most reactive metals. They all react violently with water. Resembles kind of like dynamite or hand grenades when they're thrown in water. Alkali metals are never found as free elements in nature. They are always bonded with another element. And that makes sense. If they're extremely reactive with water, then water is everywhere in the natural world. They cannot be found pure in their pure elemental form because they've all reacted up, or it would be a very, very, very bad situation. Pure elemental alkali metals have to be stored in really watertight cases or containers to keep them from reacting. And that's where we'll stop today. Be sure you complete the video form, and we'll continue on with families tomorrow. Let me know if you have any questions. Thank you.